to do is we are going to create two binomials that we're going to end up multiplying together. So we're going to create these two binomials in reference to a particular situation. So these are all word problems. Okay, so emotionally prepare for that. These are the steps, and they're going to make no sense to you when I say them. We're going to identify the quantity to be maximized or minimized. We're going to define the variable. So we're going to say let x equal the number of extra trees. Step 3, most difficult part, we're going to write those two binomials. But you can only use one variable in them. The thing that you defined in step 2, you're going to multiply your expressions together. That's going to give it to you in standard form. And then you're going to have to convert to vertex form. And then you're going to have to answer some questions about it. Okay, here we go. An orchard has 200 trees per hectare. Okay? The average yield is 300 oranges per tree. How many trees in total? Or how many oranges in total? 8 word problems. Okay, so I got 20 trees and 300 oranges per tree. I don't know why I can't get this right. And you want to put this off to the side, guys. I did mine in pencil because we're going to do a whole bunch of other math, but we're going to get my calculator and we're going to do some stuff. We're going to take 20 times it by 300 and we're going to get 6,000 oranges. Isn't that exciting? All right, and how we got the 6,000, maybe I'm going to erase that. I'm going to go 20 times 300 gave me the 6,000 oranges. And that, like, you guys are like, yeah, I know how to do that. But now we're going to read the next line. It's estimated that for each additional tree beyond the 20, so every tree that you add beyond 20, the yield per tree is reduced by 10 oranges. So if I'm at 21 trees, how many oranges per tree? If it were 290, right? Because we're reducing by 10. All right, so that is 6,090 oranges. So that's good. We're still going up in oranges. That's exciting. If I have 22 trees, how many oranges does each tree produce? 280. Good mathin'. Good mathin', and then I don't write it down right. Not very nice of me. 6,160. If I have 23 trees, how many oranges per tree? 270. Okay, if I have 24 trees, how many oranges per tree? 260. This is exciting. Okay, maybe it's not that super exciting, but, and that would be 250 trees. You're like, how long do we have to go? Those are very valid questions. So this is the problem with the strategy I'm using now, is that we don't know how far we have to go. When will we know when this is over? Please make it end soon. Where do you think we should stop? There is a stop. It starts going down. Have I started to go down? Yeah. Okay. So how many trees per hectare will give you the largest yield of oranges? So what's going to give us the most oranges? How many trees? 25. What you found there was kind of the vertex. Well, it is the vertex. You went up, up, up. You kept climbing. You hit the vertex, and then you started to go down. So I know that I want to plant 25 trees. That's going to give me the maximum number of oranges. The trouble with this strategy is that what happens if it's not oranges, it's money, and you can do halves. You could do quarters, you know, like, so all of a sudden it gets very complicated. You could have a lot of other numbers, like maybe this wasn't our vertex, maybe we're gonna get to 70 trees per hectare, and that gives us a max. You know what I mean? Like doing this way is a really long way to do it. So now I'm gonna show you how to do it. I won't say the easier way, because it's definitely not the easier way, but we're gonna do it this way. Okay, so I just wanted to prove to you, you guys know what the answer is now. You know the answer is 25 trees. You've got the answer, 100%. But we're gonna do it creating that quadratic equation. And I'm not sure why I'm using a pencil, but I am. Let me grab my pen. All right, so step one, identify the quantity to be maximized or minimized. What am I looking for? We're looking for a max or a min. So what do we want? We want a max number of oranges. So right away, when I'm looking for a maximum, which way does my parabola open? Down. So what do we know about the A value in our parabola? Has to be negative, right? So there's some things you already know about the equation because you're just generally smart people. But so when you do this math, you can be like, okay, I know I'm looking that my x squared has to have a negative on the front of it. Okay. But what was the thing that we were trying to figure out? It was the number of trees, right? We're trying to figure out the number of trees. So we're going to make a statement, let x equal the number of, oh, look, I forgot a t in there. Because we're adding one tree every time. We're adding in an additional tree on top of the 20. Okay. So we want the max number of oranges. It's going to equal something and something. Something and something. Do you like that? You're going to create two binomials, the something and somethings. Okay, one's going to talk about your trees, and one's going to talk about your oranges, because those are the two things we're looking at. All right, how many, and you always start with the number given. How many trees do we start with? 20. How many oranges do we start with? 6,000. Okay, maybe per tree, because what did we do here? We had to multiply the number of trees by the number of oranges per tree, right? So we're kind of modeling that situation again. So the number of oranges that we start with is 300 per tree. So this information is going to be located in the question. And there are two different things. You'll deal with money and quantity. So money will be in one binomial, the quantity will be in the second binomial. You don't put those two numbers in the same binomial. So what were we doing to the trees in every line? What were we doing to them? No, trees. What? We were adding how many? 1. So we're going to add 1 tree each time. But what did that do to our oranges? For every tree, we subtracted 10. So notice that my x is in both of these places. So the x stands for the number of additional trees. If I have 1 additional tree, how many oranges do I have? 290, right? If I have 2 additional trees, I have 280 oranges. You guys did all this math. You had no problem doing it here, but the hard part is taking like what makes sense, like the numbers make sense, and making it into like an equation with letters and stuff in it. But we've just done the hardest part. So this variable and this variable will always be the same letter. And it will be the thing that you defined here. Okay? So you start with the information given in the question. Keep your binomials separate, one about trees, one about oranges. They're going to end with the same letter. And the whole point of this is figuring out what's the total of oranges. Okay, we got to multiply. 20 times 300, I think we've done that already. That's 6,000. So I like to draw in my arrows. You may not like to do that. That helps my brain. Okay, if I start with an equal sign, that equal sign has to follow me down, okay? Has to follow me down the page. If there's, like, we haven't done any calculations on this side, so you can just leave it blank. You don't have to write it in. So I'm going to have 6,000 plus 100x minus 10x squared. It does not work for me to have my x squared at the back of the bus. I can't see it, I can't do math with it, it doesn't work for my brain. So I'm going to rearrange it with the highest exponent first and then work my way down, because I don't know, I've been trying to train you guys for years. So I'm going to rearrange this. But remember, you got to take the sign in front of it. So like the 10x squared is actually negative 10x squared, and the 100x is actually positive 100x. So just keep that in mind. So negative 10x squared plus 100x plus 6,000. Okay, now we're going to complete the square on it. So now you got to follow all the rules from yesterday. So that's why I suggested you practice that. But that's okay. If you didn't, it's okay. We'll only cry a little bit. Step one. What was step one? Bracket. Step two. We're going to factor out the coefficient on the x squared, but only out of the brackets. Oh, I have not let myself enough room. I hope you guys left yourself enough room. What's step three? That's my side note. Yeah, the thing I do on the side. So the side note is related to the coefficient on the x. So we're going to have negative 10 divided by 2, and we're going to square it. So we're going to have negative 5 squared is 25. What do I do with that 25? Add it inside. Subtract it outside, but what do I have to consider? Times that negative 10, right? Because there's negative 10 of those, so there has to be negative 10 of the thing we put on the outside as well. What goes inside that bracket?
5, negative 5.
Yeah. Remember, it's that piece right here, so it's going to be x minus 5. And then I got to do this math. I got 6,000 plus 250. All right, that doesn't tell me a whole lot, but it does tell me where my vertex is. So my vertex is at 5 and 6,250. What does the x represent in my vertex? You defined it before. Here, hang on. A number of additional trees. So if I started with 20, and if I want to know what the trees are, you have a binomial about your trees. You can substitute, you guys agree that this is the x value, that's the y value? So the x value, I know I need 5 additional trees to get the maximum yield, and we said that y was equal to the max number of oranges produced. So this represents how many oranges are in the max. I really hope you guys left more room than I did. Are in the max, and the 5 tells me how many more trees I need. So I need 5 more trees, so that means I'm going to be at 25 trees in total, and that's going to give me 6,250 oranges. And we knew that was the answer already from the work we did in our table. but I'm not sure I would use a table of values all the time. It gets kind of cumbersome and long, and I cry a little bit. Redundant even. Cumbersome and redundant. There you go. There's two big words for today. All right, let's keep rocking and rolling. Okay, so this is why I would never do a table of values for money. What can money be broken down into? Loonies, toonies, cents. I can have 100 pennies. Do you really want to do a table of values per penny? Nobody's got time for that in their lives, right? So there's a benefit to doing a table of values, and if that's the only strategy you know how to use, then run with it. It just may take you a really long time. But mathematicians, we like to work smarter, not harder. Okay, math computer software programs are sold for $20 each, and there are 300 students willing to buy the software at that price. Ms. Scallion did some market research and found out that for every $5 we increase the price, 30 fewer students would buy the product. What price of the software would maximize the revenue? That's a lot of words. What are we talking about? Want to know how much we're going to charge for this program, right? And how much money we're going to make from that. Okay, so what's the thing that we're increasing? We're increasing the money, right? So we're going to say let X equal number of times we increase the price.
How do we decide what we want that X value to be?
Oh, wait, like what? So it's going to be the thing that controls it. Like when I increase the price, it does something to how many kids buy it. So we're always looking at the thing that's going to increase or decrease, kind of the role in that. I don't know who's calling me in the middle of the day. Okay, so we're going to start with that. If you are hung up on this, don't, I'm going to say this with all the love in my heart, don't do it. If this is the thing stopping you from moving on to the next steps, you can always do the math and then go back and add this in later. I'll never know in what order you put it on the page. Or if you don't do this part, it's a half mark. Like doing this question is going to be a 4-mark question. And if you get stuck here and you can't move forward, like you're like, oh, I spent all this time trying to figure that out. It's only worth a half mark, and it's not as important as the math that's going to follow. Okay, we got 2 binomials. And what are we looking for here? We're looking for max revenue. All right, what are my binomials about? The other one was like trees and oranges. This one's about money and students, right?
Do we put like the dollar signs and everything?
I wouldn't till the end. I don't use units until the very end because there's so many variables and so much other stuff going on. I don't think I'd worry about it. Okay, money. What's the money we're starting with? What number are we gonna put in there? 20. Okay. What's the number of students we're starting with? Hopefully 300. I was gonna say 30, but 300, right? Because we know 300 students will buy it at $20. So those are my first numbers. Okay, what do we want to add to the price? We're doing it in $5 increments. We're not adding $1, we're not adding $2, we're adding $5 each time. Okay, so $5 once would be a price of 25, $5 twice would be a price of 30. You get kind of like the pattern? It's building, sort of, kind of. And what happens to the students when we do that? We lose 30 of them. So for every time we increase the price, we lose 30 students. So that's why X is the number of times, not the amount, because we know the amount's $5. We're only increasing in $5. We don't have time for change. We're going to give out dollar bills. We're not going to deal with loonies and toonies. So this is the number of times we increase the price. Not by how much, but how many times we increase the price. So now we just got to multiply it. Go forth, multiply. Do the multiplying. Okay, you guys multiply, I'm gonna answer the phone. Hello? Hey. Yeah, for sure. Okay, no problem, bye-bye. Hayden. No, when we're done the lesson, you're gonna go see Courtney,
Okay.
okay?
Yep.
She knows how important this is. She understands how important this math is.
Numbers.
Oh, bring the next square down there. How do we feel about that? I rearranged it and I combined like terms. Did I combine them correctly? I didn't draw my arrows. 600, 1500, 150. Oh, I just get lost when I don't have my arrows. All right, so you've done the hardest part by putting these together, like by doing that. Like you've done the hardest part. Now we're looking for the maximum. So if we're looking for the max revenue, we know that we're looking for the vertex. So we're going to convert it to vertex form. Is everybody with me here? Like, are you guys done writing? I don't want to keep, sometimes like, left alone, I go way too fast. And if you guys don't say anything, I'll continue to go way too fast. So step 1, we're going to group our x's. Step 2, we're going to common factor out that negative 150. So I'm going to take 900 and I'm dividing it by negative 150. I'm going to leave some space, close my brackets, and put my 6,000 there. So that's steps 1 and steps 2. So I only take the 150 out of what's in the brackets. I don't touch that 6,000. So now we're going to do our side note. Can you do your side note in your head? Good point, you shouldn't do that because we need part of it later on. So we get a positive 9. So we're going to add 9 in here. We're going to minus 9 out here, but we have to multiply that minus 9 by the negative 150. What goes in that bracket with my x? Should be the negative 3. Remember that you got to take that sign with it, so it's going to be minus 3. Okay, so I get negative 150 x minus 3 squared plus $7,350. Where's my vertex?
3 and 7,000.
Okay, what does that mean though? This is my x value. So what did the x value mean?
If you increase the price by 3 times,
Mm-hmm.
students 7350.
We're gonna make $7,350. So this is money, and this is how many times we increase the price.
But then we put the amount of students in our wage salary.
Mm-hmm. But we put the amount of students in, but what does our x represent? Our x represents how many times we increase the price. So that's what they're related to. So how much are we charging per software to get a maximum revenue? $35. So if you're wondering how I got that, I'm going back up to the cost binomial. You guys told me well, you didn't tell me, the math tells me that how many times do we increase the price? 3 times. So we're gonna take 20 plus 5 times 3, so 20 plus 15. We're gonna be charging $35. Hope your notes are nicer than mine. Didn't leave us a ton of room. Do you think you can do the next one? Or do you want to still do it together? How about you guys I'll do the defining the variable. You guys create the binomials. How about that? No. Yes, they're welcome to our world. It's panic all the time. Okay, I did my part. You guys are now on the hook to create those 2 binomials. The nice thing is this is almost like the question above. We got money and we got the number of water bottles, right?
Does that look like a jet?
Hmm?
That looks like jet XB.
Oh, let. Look, I do my best. I do my best.
Trying to see my next book. 3,000. Yeah, I think it's cute. But I'm not gonna. Yeah. Or a car. Money for shopping. She might have promised. Promised me she will.
Okay, if you guys can get it into standard form, like if you can just multiply those 2 binomials, that would be delightful, but don't go any further than that just in case there's a mistake in it and you gotta erase stuff and. Okay, let's see if you got what I got. Yes? Each water bottle costs $8, right? What? Oh, it's only 100. All right. You guys and your accuracy. It's like it never happened. Look at this. It's like it never happened. No. Okay, so I can't add. Oh, you guys are so picky. What do we got? 160? Okay, so it kind of did happen because I had to fix it twice. But did your binomials look like mine besides the 1,000?
Yeah.
Where did I get the 1,000? I don't know. Reading is hard. Very hard. No judgments.
Yeah, I think.
Oh, right, because this is what happens when you multiply by 1,000 and don't fix all of it. Let me fix all the pieces. All right, so is my math correct? Maybe I shouldn't ask if your math is correct. Maybe I should ask if my math is correct. Okay, so we're there. So now all we're doing is completing the square. So we're factoring out that negative 10 just out of what's in the brackets. Sorry guys, I did my math wrong. I hope you're doing your math better than me. There we go. Whew. I don't know why I'm tempting fate and trying to do mental math today, because it's obviously not working for me, but I think I got this one. So now we have the vertex at positive 8 and 1440, that y is my max revenue, and the 8 is how many times I increase the price. Did you? Sorry. I'm trying to jam things in everywhere. Okay, but the question asks, what quantity of water bottle will produce the largest revenue? It's not asking the cost per water bottle. It's asking something about the number of water bottles we're selling. So what binomial am I going to substitute into? I'm going to do this one because it's a question about the number of water bottles. So I'm going to substitute in 8, but I'm substituting it in here. So
Just in the water bottle part?
because what does the question ask? What quantity of water bottles? Doesn't say what price we need to sell the water bottles at. So you got to be careful about what the question's actually asking. So we need to sell 60 water bottles, and how much would we be charging per water bottle? Just as an additional question, because I like additional questions. How much am I charging per water bottle?
Don't you just put it in?
Yep.
So, 24?
24 bucks. 24 bucks a water bottle, and I gotta sell 60 water bottles, and I'll get a max revenue of $1,440. Not too shabby. Okay. So now, I would encourage you to do today's assignment. Okay, I'm gonna encourage you to do 3.3 part 1 first. You've got to get good at completing the square, and then add the extra layer of the word problems. Okay, good luck.
What is that?